In this video, we'll learn about trigonometric ratios of some specific angles. We'll be seeing ratios for 0 degrees, 30 degree, 45 degree, 60 degree and 90 degree. Then finally, we'll construct a table and try to remember them for our further use. First, we'll see trigonometric ratios for angle of 45 degree. Consider a triangle ABC, which is right angled at B, and it's an isosceles triangle. Isosceles triangle means two sides of a triangle are equal. Consider those sides to be AB and BC and let them be A, which implies angle A is equal to angle C according to the property sides opposite to equal angles of a triangle are also equal. So it comes to be 45 degree according to angles and property of triangle. So using Pythagoras theorem, we'll estimate the size of AC, hypotenuse. AC square is equal to AB square plus BC square. AC square is equal to A square plus A square is equal to 2A square, which implies AC is equal to square root of 2A square, which gives root 2A. Now we'll see sine 45 degrees. By our previous video, we know that sine is opposite side by hypotenuse. What is the opposite side? Opposite side of angle A is AB. Hypotenuse is AC. AB is A and AC is root 2A. We get 1 by root 2. Similarly, cos 45. It is adjacent side by hypotenuse, which is equal to BC by AC, which gives A by root 2A, which is in turn 1 by root 2. Tan 45 is opposite side by adjacent side, which is equal to AB by BC, which is equal to 1 by root, is equal to A by A, which is equal to 1. Similarly, we can derive cosecant theta, secant theta and cot theta, which are the inverse of sin theta, cos theta and tan theta respectively. Cosecant 45 is the inverse of sin 45, which is equal to hypotenuse by opposite side, which gives rise to root 2A by A, which is equal to root 2. Secant 45 is equal to 1 by cos 45, which is equal to AC by BC, which is equal to root 2A by A, which is equal to root 2. And cot 45 is equal to 1 by tan 45, which is equal to cos 45 by sin 45, which is equal to root 2 by root 2 is equal to 1. Let us remember all these in the end of the video. Now let us see trigonometric ratios for angle 60 degrees and 30 degrees. Let us initially construct an equilateral triangle ABC with sides being 2A. And then construct a perpendicular AD dividing the line segment BC into half, which makes BD is equal to A and DC is equal to A, which also divides the angle A 60 degree equally and creates a 30 degree. By this construction, we will be knowing that triangle ADC is congruent to triangle ADB by RHS property, which implies AD is common, AB is equal to AC, BD is equal to DC and AD is the common one. Angle A is 30 degree, angle B is 60 degree, angle D is 90 degree. Now let us see for 60 degree ratios. Sin B, that is sin 60 degree, is equal to opposite by hypotenuse. Before that, we have to know the size of AD. By using Pythagoras theorem, AD square is equal to B square minus BD square, which is equal to 2A the whole square minus A square, which is equal to 4A square minus A square is equal to 3A square, which in turn gives AD is equal to root 3A. Sin 60 is equal to AD by AB, which is equal to root 3A by 2A, which gives root 3 by 2. Then coming to cos 60, which is equal to adjacent side by hypotenuse, which is equal to BD by AB. BD is A and AB is 2A, which in turn gives 1 by 2. Tan 60 can be written as sin 60 by cos 60, which is equal to root 3 by 2 divided by 1 by 2. Cancelling 2's, we get root 3. Cosecant 60 is the inverse of sin 60, which is equal to 1 by root 3 by 2, which gives 2 by root 3. Secant 60 is the inverse of cos 60, which gives 1 by 2, which is equal to 2. And cot 60 is cos 60 by sin 60. It's equal to 1 by 2 by root 3 by 2, which is equal to 1 by root 3. Now, we look for 30 degrees. In triangle ADB, consider angle BAD is equal to 30 degree. Now seeing for sin A, sin 30 degree. Opposite comes to be BD and hypotenuse is AB. We'll write it down. We'll construct a small triangle here. Triangle ADB. A is 30 degree. AD, AB is 2A, BD is A, and AD is root 3A. Now let's derive sin all trigonometric ratios. Sin 30 is opposite by hypotenuse. BD by AB, which is equal to A by 2A, which is equal to 1 by 2. Cos 30 is equal to adjacent by hypotenuse AD by AB, which is equal to root 3A by 2A, which is equal to root 3 by 2. Tan 30 is equal to opposite by adjacent, which is equal to BD by AD. What is BD? BD is A by AD is root 3A, which is equal to 1 by root 3. Cosecant 30 is equal to hypotenuse by opposite side, AB by BD, which is equal to 2A by A is equal to 2. Secant 30 is equal to hypotenuse by adjacent side, AD, AB by AD, which is equal to 2A by root 3A, which is equal to 2 by root 3. And cot 30 is equal to adjacent side by opposite side, which is equal to AD by BD. Root 3A by A, which is equal to root 3. Now, we'll consider trigonometric ratios for angles 0 degree and 90 degree. Initially, we'll see it for 0 degrees. It is construct a triangle ABC with B being right angled. We'll make the angle A as 0 degree by constructing lines, which implies in turn AB becomes AC and there will be no BC, which implies BC is equal to 0. This in turn gets converted to a single line ABC. Angle A becomes 0. So what is sine 0? Sine 0 is opposite side by adjacent side. That is BC by AC. Now BC has become 0, which implies sine 0 is 0. Cos 0 is adjacent side by hypotenuse. That is AB by AC. Now we have derived that AB is equal to AC by making the angle A 0. Which implies AC by AC is equal to 1. That is cos 0 is 1. Tan 0 is sin 0 by cos 0. That is nothing but 0. 0 by 1 is 0. Similarly, cosecant 0 is inverse of sine. Now we have got sin 0 as 0. 1 by 0 is undefined. Secant 0. Secant 0 is 1 by cos 0. That is 1 by 1 is equal to 1. Cot 0. Cot 0 is also undefined because it is the inverse of tan. 1 by 0 is undefined. Now, for angle 90 degree, we'll again consider a right angle triangle, right angled at B. Now, we will make angle A to 90 degree. This time, angle C becomes 0 and angle A becomes 90 degree. And we'll also find out that AB becomes 0, BC is equal to AC. Now, sin theta, sin 90 is equal to BC by AC. We know BC and AC are equal, so AC by AC is equal to 1. Sin 90 is equal to 1. Cos 90 is adjacent by opposite side, that is AB by adjacent by hypotenuse, that is AB by AC, which is equal to 0. Tan theta, tan 90 degree is undefined as the denominator becomes 0. And we'll get to know the inverses of other things. Cosecant 90 is the inverse of sin 90, that is 1. Secant 90 is the inverse of cos 90, that is equal to undefined. And finally, we have cot 90, which is the inverse of tan, that is equal to 0. It can also be written as cos 90 by sin 90, that is 0 by 1 is equal to 0. So now, finally, as a summary, we'll construct a table. We'll have all the angles in the left side and like trigonometric ratios on the left side and angles above. We have seen that sin 0 is 0. Sin 30 is 1 by 2. Sin 45 is 1 by root 2. Sin 60 is root 3 by 2 and sin 90 is 1. We know that sin and cos are complementary to each other on base of angles. Cos 30 is root 3 by 2. Cos 45 is 1 by root 2. Cos 60 is 1 by 2, cos 90 is 0. Tan is sine by cos, so we'll divide both things. 1 by root 3, 1, root 3, and undefined. Cosecant is the inverse of sine. So 1 by 0 is undefined, 1 by 2 is 2, 1 by root 2 is 1 by root 2 is root 2, 1 by root 3 by 2 is 2 by root 3, 1 by 1 is 1. Secant is the inverse of cos. 1 by 1 is 1, 1 by root 3 by 2 is 2 by root 3, 1 by root 2 is root 2, 1 by 2 is 2, and 1 by 0 is undefined. Cot theta is cosecant cot theta is cos theta by sin theta or the inverse of tan theta. 1 by 0 is undefined. 1 by root 3 is root 3. 1 by 1 is 1. 1 by root 3 is 1 by root 3. And 1 by undefined is 0. We have to remember this table for our further uses. Further, as an easier step, we can write the sin theta easily and show it. Sin theta 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. We have to write this and then write 0, 1, 2, 3, 4, and as a denominator put 4. Take square root in all of them. 0 by 4 is 0 and square root is anything is 0. 1 by 4, 4 square root is 2. So we'll get 1 by 2. 2 by 4 is 1 by 2. So 1 by root 2. This is root 3 by 2 and this is 1. So we'll get to know that this matches with our sine table. This is an easier method. It can be used as a memorizing tool. So in this video we have learned about the trigonometric ratios for angles between 0 to 90 degree. We'll have to remember this table for our further uses. Thank you.